This video explains how to use the MEPworks Psychrometrics program. So you can see here we're in the mechanical menu. We don't have a floor plan selected, so we're doing a non-floor plan based job. And you can see here the Psychrometrics icon. Click on the icon, starting with a new file. And filling out the job reference. There are a list of standard systems you can apply here, so you can pick from one of our prefixed systems. What I'm going to do is show you how to create your own system. So we can cancel this dialog box, and this will present us with a grid. The idea being to drop the icon onto the grid to create a system. Selecting the air supply, selecting the mixing box. I can then apply my fan, apply a cooling coil, a heater battery, selecting a bend, selecting another bend, drop it on the layout with a right button click, and that'll swing it around so that it sets up properly. I can then insert my zone. I can put just a straight section of ductwork in, my extract fan, my dividing T so I can introduce recirculated air, and finally my exhaust to atmosphere. I'm now in a position to be able to start the calculation from the display menu, selecting Calculate. This presents me with a psychrometric chart, and the screen split into three sections. You can see here the psychrometric chart, the data entry dialog box, and the layout. On the display menu I can show extended details, so when I calculate a system it gives me details about the position I'm looking at, and also I can show a detailed chart. And of course, in usual Windows style, you can move these dialog boxes around the screen. To actually enter the data you have to select from the layout. So if I, for example, go to my room zone and load and enter a sensible heat gain, enter a latent heat gain, the temperature rise across the space, and the room condition at position 9, which is effectively the extract. So I'm holding the room at 21 degrees and a saturation of 55%. I then click once on the screen and that creates my condition. There you can see this applied to the room with your 8-degree delta T. You can see the change in moisture content with the increase in moisture based on the latent, giving rise to position number 9. 21 degrees. What I can do now is go to my atmospheric condition, the input from outside, specify the external weather condition and the saturation. Again, clicking on the layout will revise that, and there's my outside condition. 28 degrees, 75% saturation. To get the cycle going, I can either select the return or supply mixing box and start off with a 50-50 percentage. This merely gets the cycle going, and you can now see under those conditions we've got our cooling requirement and our sensible heating requirement from our heater battery. The reality of the situation is usually we have a minimum fresh air requirement that we are legally obliged to input into the building. We can do this by monitoring the requirement by going to the first position, ticking on the box and selecting monitor position 1, and this will give us currently the flow rate at 50% supply, 50% recirculation. Based on occupancy levels we may actually only have a minimum fresh air requirement of 2 cubic meters per second, so we can modulate the return air mixing box until this flow condition gets as near as we can down to 2 meters cubed per second. We can then enter the return mixing box and we can start increasing using the up arrow tab key on your keyboard, and you can see this figure on the flow in position 1 is now beginning to reduce until we get down as near as we can to 2 cubic meters per second. Under those conditions, to meet minimum fresh air requirements, our cooling load is reduced to 281.9 kilowatts, and our heating is 36.8 kilowatts as before. If you adjust the external temperature, this will obviously have a bearing on the condition. Again, any numeric entry can be toggled up and down using the up and down arrow on your keyboard, and there you can see the situation based on the external weather condition. Note that on this particular cycle we don't have any form of humidification, so there will come a point where the program cannot calculate because it needs to know the humidification. You can see here it's telling you the moisture content can't rise. We have no means of humidification, we haven't entered this in, so we would need to create a new cycle and introduce some sort of humidifier in order to get the cycle to work again. We return back and then we can reintroduce the system. So effectively you're selecting various sections of the layout, and you can see the calculated results on the data entry. Any entries that you want to be calculated, you need to enter as a series of 6 asterisks. So for example, earlier on in the calculation we wanted to predict the flow rate. We can relax one of these. So for example, if I want to look at the temperature rise within the space if the minimum fresh air requirement is actually 3 meters a second, if I enter 6 asterisks and then go back to the supply condition and physically type in 3 cubic meters per second, the program now performs a recalculation so that when I go back to the room space, the actual temperature rise is 5.59 degrees. A trap a lot of people fall into is trying to overspecify. Trying to specify a temperature rise and a supply condition and a room condition is based on an iterative cycle. Is trying to make 2 and 2 equal 5. You can't do it, so you have to relax some of the data entries, as I did earlier, by entering the 6 asterisks. You can actually display the extended details as well about each part of the system. If I wish to look at the conditions off and on the coil, I can display extended. That gives me all my psychrometric conditions. If I wish to look at the supply condition, I can see that entry there as well. Any data on the extended view that's highlighted in bold are engineer entered data entries. The grey is calculated. So you can actually create all sorts of different systems by putting together your own icons and looking at various systems